Let's take a look at Unit 5, Transformations of Functions, Lesson 7, Expressing Transformations of Functions Algebraically. All right, so in 7.1, we are describing translations, and we're letting g of x equal the square root of x. So we're going to complete the table and explain our reasoning. So we're going to translate the graph left 5 units. And so the function notation is g of x plus 5, because remember, left is positive and right is negative. And so we would end up with the square root of x plus 5. All right, the next one, we're translating left 5 units and down 3 units. And you can see the expression is the square root of x plus 5, and then subtracting 3 from that. So g of x plus 5, and then we're going to subtract 3. All right, if we're taking g of negative x, then that's the square root of negative x, and we are reflecting. And remember that when we change the input value, when we change the sign of the input value, we're reflecting across the y-axis. If we were changing the output value, if it was negative g of x, we would be reflecting across the x-axis. Okay, so the next one, we're going to translate left 5 units, then down 3 units, then reflect across the y-axis. All right, so we have g of, remember that our x is negative, we're adding 5, and then we're subtracting 3. So we have the square root of negative x plus 5, and then subtract 3 outside of that radical. Okay, so let's take a look at translating vertex form. So we have letting f be the function given by f of x equals x squared. Remember, that's a quadratic function. Write an equation for the function g, whose graph is the graph of f translated 3 units left and 5 units up. So g of x is equal to, and this is basically like, remember that f of x equals x, oops, that was supposed to be an x minus h quantity squared plus k. That was the vertex form where the vertex was hk. Hopefully you remember that. So if we're translating to the left 3 units, that's going to make our h a negative 3. So it's x plus 3 because it's x minus a negative. And then we're going up 5 units, so we're going to add 5 to that. Hopefully you remember that from Algebra 1, where you're changing the vertex. And that's basically shifting the whole graph, in this case, left 3 units and up 5. So the vertex, remember, is hk. And if it's in the form x minus h quantity squared plus k, then h is actually negative 3, because if h was 3, it would say x minus 3. And k is positive 5. So your vertex is the point negative 3, 5. All right, we're going to write an equation for a quadratic function h that has a vertex at 1.5, 2.6. So h of x is equal to x minus, and then we're going to plug in our h value, 1.5, quantity squared, plus our k value, which is 2.6. And really, we have a coefficient here in front of the x minus 1.5 quantity squared, and that could really be anything in that case, because it didn't say whether or not there was any kind of stretching or squishing going on. Okay, so let's take a look at number 4. Write an equation for a quadratic function k, whose graph opens downward. So now we know we need to reflect across the x-axis, and has a vertex at 3.2, negative 4.7. All right, so we're going to have, this is k. So we have k of x equals, and remember, we're going to reflect over the x-axis. So we're going to have a negative a. That can be any value. It could be a 1. We could put negative 1. That's fine. And then x no, not plus, minus, because that 3.2 is positive. So minus 3.2 quantity squared minus 4.7, because that's a negative 4.7. Okay, let's take a look at 7.3. In an earlier lesson, we looked at temperature, T in degrees Fahrenheit, of a bottle of soda water left outside for h hours. Let's model this data with a function. This time we will start with the function f of h equals 33 times 0.6 to the h. This graph has a shape that fits the data pretty well. All right, so we have these points on the left-hand side, and then we have a graph on the right-hand side. So what kind of translation would help this graph fit the data? Well, if you look here, we have a starting value around, I don't know, 33. Well, that should be 0.33, not 33, 0.33. And this point is around maybe 0.68. So we might need to shift up, what would that be, 35 units. So we want to maybe go up 35 units, and yeah, so we could do translate up 35 units. Now let's see what that might do to some other points. So we've got this point 3, looks to be about, I don't know, maybe 8. And then here we don't have a point 3, but we have this one that is about 2.8, 53 maybe. And so that one's shifted kind of to the left. So up 45 and to the left 0.2. So just translating up 35 units might not be enough. So if we take a look at the applet on our I Am Kendall Hunt website, we can actually play around with this a little bit better. You can see the data points in green that are the same as the left-hand side of our left-hand side graph. And then we have our equation. And our A value is 33, our B value is 0.6. So let's try doing some shifting here. We'll add our 35 that we had, and let's see how that goes. So you can see it's getting closer, but not quite. The curve doesn't quite fit. So let's raise it up a little bit more. Let's go to 45 and see how that fits. Oh, that's fitting a little bit better. But we might want to shift it over to the left a little. So let's add something to our H value. Let's add just a half, 0.5. See what that looks like. Oh, that fits quite well, actually. So maybe instead of translating up 35, we'll translate up 45 units and then left a half a unit. Right? So our equation is going to say f of h, actually it should be g, yeah. So g of h is equal to 33, that didn't change, times 0.6, and then we shifted left 0.5, so we're adding that to the h, and then we went up 45 units, so we're adding that to the whole expression. So our function tells us that the temperature outside has a horizontal asymptote of 45 degrees, or 45. So it has a horizontal asymptote at 45. So the temperature is not going to, oh wait, hold on. 45, yeah. So the temperature probably will not go below 45 degrees because it has that horizontal asymptote there. Because if you see, it keeps on going and going and going, and it kind of flattens out at 45. So the temperature is 45 degrees. Oops, can't spell today. And as always, there's the lesson summary if you want to take a look at that.